Hello everyone, hope you're all doing fine. Welcome to another video of IT project management. So in this lecture we are going to study unit 2. We have already completed unit 1. It was good. Your feedback was super positive. So let's continue the flow and start with unit 2. So what is unit 2? What we are going to study here in unit 2? So the first is project scheduling. The project scheduling, it is basically how we define the project in a particular timeline. So what is PERT model, what is CPM, critical path calculation. So it includes a lot of calculations. So I request you to please focus on this lecture. This is one of the most I would say difficult lecture, to be very honest, because it requires your analytical skills and it has also some numericals that might come in the examination. So let's start without wasting the time. Okay, let's start. So the first we're gonna study about project scheduling. What is project scheduling? What is the introduction of it? Let me just quickly zoom in to you. I hope it is visible now. So the definition of project scheduling is it is a process of listing all the project activities, estimating their duration, identifying dependency, creating a timeline for a project completion. This is called project scheduling. So what do you mean by duration and dependencies? Duration means for how much time is required to complete a particular project, and dependency means what are the resources that are required to do that. For example, I am doing a work and my work depends upon the output of some other person. So that other person is my dependency. The output that is given to me as an input is my dependency. Without this, I can't do my work. So this is called dependency. And creating this dependency, managing it, is called project scheduling. Okay, we discussed it. Now, why this scheduling is important? I don't know why. So this scheduling ensures the task will be done on a certain order, on the right order. It helps us to identify the possible project completion date so that we don't have to worry. Allow resource planning. We can plan our resources, like identify critical activities that can't be delayed. Provide a baseline for tracking actual progress. So these are the things that are required for a project scheduling. You can see project scheduling process. Yeah. Now we are going to study about PERT. What is PERT? So PERT is program evaluation and review technique. So it's like very simple. PERT is basically based on the history. It is developed by US Navy. US Navy for project management. Like they're holding some operations and they want to use some scheduling technique. So they used for uncertain and probabilistic project where activities are not known exactly. Like if you don't know the activities exactly, what are the activities, how much time will that activity will take and all, so you use PERT. Like many of the times if you are project manager, you need to define you are going to manage a project, but you don't know how much time will it require to do every steps in the project. In that case, you are going to implement PERT strategy. So what is PERT strategy? Tell me. So PERT strategies contains these three estimations. It's okay. The first is optimistic time, second is most likely time, and the third is pessimistic time. Optimistic time is the best case of it, like everything goes perfectly, what should be the time? And most likely time is the most realistic estimate. So like if everything, what is the most realistic way to complete the project? For example, the best case, it would be 3 days. The most realistic take, it will be 1 month, or 7 days. And the pessimistic time is the worst case. So many problems occur in the project. If all the problems occur in the project, how much time will it take? Let's say 20 days. So with these things, pessimistic, optimistic, and most likely time, you would get the expected time, as expected time is equals to O plus 4m plus p into by 6. So you will get the expected time. You will get the variance of it. This is an example that I showed you. You can see. So here you can get expected time of 7 days and a variance of 2.78. So this shows you the PERT technique, like program evaluation and review technique, and you can do with it. The second thing is CPM. Hope it is clear to you. If you are not clear with it, you can just comment it down. I'll just clear you. Okay. So the second thing is critical path method. What is a critical path method? What is a CPM? So CPM is basically like it is a when you have a deterministic project where the activities and durations are known exactly to you. So the CPM focus on identifying the critical paths and opportunities for the crashing. What is crashing? So crashing we'll discuss in the next topic. What is crashing? Crashing is basically, you can see, okay, we'll discuss anyways. So we'll just move forward. What is a so it has like good opportunities of crashing when we are like crashing things, like basically it's like a delay thing. So when you are having a delay and you need to put some more resources on a project, then it is called crashing. And so CPM is basically defined as it is used for deterministic project where you know each and everything of the project, like the activity duration and everything, and CPM focus on this only, critical path methods. Okay. So Harsh, what kind of question can RGPV ask or any examination ask? So they ask a key difference about PERT and CPM. So you can see the key difference here. So like the developed by parameter like difference is PERT is developed by US Navy, it is developed by Dew Point, and PERT is probabilistic, it is uncertain, it is deterministic. PERT focus on time, it focus on time and cost both. Since we know each and everything about this, like CPM, that's why. So activity time is 3 estimates and it is a single estimate. So it requires a lot of R&D and it is used for new projects, but it is like going on for construction and manufacturing things. Cost analysis, it doesn't focus on. Yes, it's focus on like the cost analysis and all. Example is space missions. You don't know what is going to come, how much time will it take, but while building a construction, you know everything. How much time will that like the foundation and then everything, interior, exterior, you know everything about construction. So these are the two type of like you can say scheduling things. Now what about PERT CM network diagram? So let's move to the syllabus ones. You have seen we have done the introduction of CPM and PERT. Now we are moving to the critical path calculation and all. Okay, let's move. So this is a type of network diagram. If you see it has like activities and all. So you can see this is also a supporting graph, it is not anything else. So you see this is stage 1. Stage 1 is a process 1. It requires a certain task to be done and then it moves to stage. So with this network, this is a type of a network diagram. With this network diagram we are going to find the critical path calculation. We are going to do that. Before that, Harsh, what is a critical path? A critical path is the longest path from start to end in a project network. It is the longest path. So can you tell me by seeing this network diagram what is the longest path here? So I think it's 4, 5 and 6. A, C, E. So I think this diagrams, the critical path is ACE. This is a quick check of how we are calculating it and how. So for the critical path calculation, what we are going to do? So there are a few steps of it. Okay, also the critical path calculation, activities on the critical path have zero float. What is zero float? Will like any delay caused by the project, it should be 0. So critical path, what I told you, critical path is the longest path. In the longest path, if you are considering the longest path, that means you don't want any delay in it. Float means delay. Yani ki if you have the longest path, you can't have any delay, zero delay in that. That is the like whole point of critical path. That is why we are finding critical path. Okay. Yeah. So there were few things that was not necessary to be there in the video. So I just removed that part, like the steps and all. And if you like wanted to do a deep understanding of critical path, you can watch any videos of it, any example of it, but we're gonna discuss one example here in the end. So we calculated the critical path. As you can see from here, critical path is basically the longest path from start to end during a project network. Now we are going to discuss about precedence relationship. What is this relationship? Like, this is basically a set of words that are required to represent a relationship, like finish to start. So B starts after A finish, which is uses in most common cases. Test start after coding ends. Start to start, B starts when A start. Typing and dictation start together. Finish to finish, B finish when A finish. QA, quality assistant, quality analysis finishes when development finishes. Start to finish, B finishes when is A start. So night shift ends when day shift starts. So this is basically the precedence relationship terms or activities that we are using in general project management. Now is the float calculation. So what is float and everything? This is just there is a very rare chance it will come in the examination. For the sake of learning, you can just refer to any other resources or reference books for this thing. So float is just, you can say it's called a stack. Like, there are few terms generally. So the few terms are LS, that is latest start. Let me just write it out quickly. LS, LF, ES, EF. Not necessary to remember this. I'm just latest start, latest finish. This is early, I think so. Maybe here it is written. Early start, early finish. Yeah, so these are the terms. Using these terms we calculate float. What is float? Float is basically the critical path should have zero float. It should not have the delay. So it is a stack of amount of time. It is like a stack which has the amount of time an activity can be delayed without delaying the project completion date. Matlab in the sense is, if you have a project or whose deadline is 15 days, then what should be the stack of, like, what should be the excess delay? For example, you have to finish it in 15 days, you can say, and you have a certain amount of stack. The amount of time of an activity can be delayed. Like, you are currently 70% done and you are still at 7 days. Okay, so you understand, 70% done. Now to complete 30%, you have around 7 or 8 days. So it is the amount of delay without delaying the project's completion date. How much delay you can do, that is the float value, that is the float thing, that is the excess buffer value that you have. So there is a formula for calculating the float and all. I don't think it will come in the examination, maybe, but you just know for the sake of learning. So the float, there are mainly two types of float: total float, free float, and one more generally there is this independent float. Total float is the maximum time an activity can be delayed without delaying the project end. That is, total float is equals to LS minus ES or LF minus EF. Free float is the time an activity can be delayed without delaying the next activity's early time. Yeah. That is ES same ES minus EF, current activity. Just remember these things. Independent float does not affect the predecessors or successor activities. So these are the things. Basically, we calculate the float using this. So why float is important? Identifies the schedule flexibility of non-critical activities. Float 0 means critical, that is, it cannot be delayed, that is a critical path, and these things. Now let's move to crashing and cost reduction. What is a crashing? Crashing is a process of compressing the project schedule by adding resources, money, people to critical path activities to reduce their duration and increases cost but reduces time. So crashing is basically, from the definition it's completely clear that if you have a project whose deadline is certain, let's suppose X days, and you want to complete this project in less number of days, so you need to put in extra resources like money or people. When you put extra resources, the cost increases but time reduces. This is called crashing, the cost reduction by crashing. So this process is called crashing. So how are we incorporating cost in it? So cost के scope में is a cost slope is equals to crash cost minus normal cost divided by normal time minus crash time. Remember this formula? And with this there is an example, like normal time is 5 days, the normal cost is 500. Crash time is 3 days, so it reduces the time but cost increases 900. So cost slope is equals to 900 minus 500 divided by 5 minus 100 minus 3. So it will come up to 200 per day. So this is a step to calculate this example only. So I explained you the example. I hope you go through the steps and you can write it by your own. Next is project cost control. So PERT, like cost integration information with PERT scheduling to provide integrated time cost management. Now we studied about the scheduling and all, but now we are going to study about how we are managing the cost control in it. So there are few things that value management or the cost management you can do, like planned value, earned value, and actual cost. So these are just definition parts, so you can just go through it. It's not nothing you need to learn something here. Just go through the definition. It's just pure definitions and things you need to remember. Next is resource scheduling. Resource scheduling or resource leveling. So resource scheduling assigns resources, means to assign resources to project activities based on availability and project needs. And resource leveling is a technique that adjusts the start and end dates of the activity based on the resource constraint to smooth resource demand and preventing overloading or underloading the resources. What does this mean? This means that resource scheduling is to assign resources, that is people or equipment, to activity based on availability. That is, we are scheduling things now. So based on availability and needs. So if it is available, then schedule it. But leveling means to check the constraints to prevent the overloading or underloading of a single resource. So this is mainly two things, scheduling and leveling. Scheduling talks about the availability and leveling talks about the constraints under that of that resource. I think it is more granular based as compared to this. So what is the benefit of leveling? Prevents resource overload, I told you, ensures constrained resources, reduces project risk, improves team morale and productivity. So there are few questions like explain PERT and 3 estimate of with the formula, calculate this. So you have given this type of things, so you need to calculate it. What is critical path, how it is calculated, so you know these things. You should know critical path is longest sequence, and calculation step, first step will be the forward pass. So I didn't talked about this, I'll just explain it quickly. Forward pass compute ES and EF, that is early start and early finish for each activity, and EF is equals to early finish is equals to ES plus duration. Backward pass is equals to compute LS and LF. LS is equals to LF minus duration, and float is equals to LS minus ES. So this is what I will provide in the notes. This is the thing that, like, this is basically the steps I'll provide. No issues in that. I'll provide you the steps. I think I have one. Let me check. The thing, I removed it because I thought it's irrelevant for you guys to go this much deeper in the topic. Yep, it is there. Okay, now you can see what are the steps. It's magic. Yep. So let's see. The first step is for calculate the forward pass, calculate the backward pass, calculate the total float, and identify the critical path. So these are the 4 steps that are required to find the critical path. What is the forward pass? Let's see. What is a forward pass? So a forward pass, that means for example, you have activity called A. Forward pass, earliest start and earliest finish, EF, in forward pass. So you need to calculate ES and EF. So ES is the earliest start. So what is the earliest start of 4? Since A and B both are from the starting point, so ES of A will be 4, ES of B will be 3. What is the earliest finish of? The earliest finish is कि कब तक ये चलेगा, like it earliest start for these things, ES for both A and B will be, earliest start will be 0 and 0, and earliest finish will be 4 and 3. Got it? अच्छा इसका बताओ. For C, what is the earliest start? Earliest start means it will be 4. Why? क्योंकि जब ये 4 चल ख़त्म होगा, this activity will finish, then only this will start. And what is the earliest finish of C? So 4 plus 5, it's 9. That is its own duration. That will be earliest finish. Since earliest finish is equals to ES plus duration, तो ES क्या था 4 plus its own duration 5, that is 9. Now D के लिए what should be the earliest start? So since ये पहले B ख़त्म होगा, then ये D शुरू होगा. So its earliest start will be 3, like for ये वाला. And what is its own duration? 2. So 3 plus 2, it will be 5. Got it? Now what will be the earliest start of E? We are discussing about the forward pass, हाँ, याद रखना. What will be the earliest start of E? So यहाँ पर E is being made from 9 and 5. So we need to take the maximum. Since we are talking, the end goal is to find the critical path, and critical path में there should not be any zero, like the float value should be 0. There should not be any delay. So we are considering the worst case. The worst case means the maximum delay or the maximum time is 9. So its earliest time will be 9. Okay. Its earliest start will be 9. What is the earliest finish? Its earliest finish will be 9 plus 6, 15. So with this way, we find out the earliest start and the earliest finish. That is the step 1 is completed, that is forward pass. This is completed. Now let's calculate the earliest start. So with similar way, now for earliest start, so for the latest start, latest start and wait. Yeah. So with this way, we find out the latest, the earliest start and earliest finish. Similarly, we can find out the latest start and latest finish. So the thing is, I am just going to talk about these steps. I don't wanted to show you the example or the diagram of it and solving and finding each one of it, because it is entirely a different thing. It is entirely a project management thing. So we don't need to focus on calculating this. We just need to know how to calculate it. Nothing else. I don't want you, I want you guys to learn it and just do it, but it is not required for the examination. I'm talking about this. So you can just follow these steps. You can just write these steps, what is there. I also like have put you what are the things you need to think basically think of to calculate these things. How are these calculated? Okay, and at the last, if you have this forward pass, backward pass, That means you have the values like ls, es or lf, ef. Then you need to like subtract it, ls minus ef, and you will get a float. And if the value of float will be 0, then that will be your critical path. That is the only thing that I wanted to say you, like here if you see. So if the float is 0, that will be the critical path. Tells minimum project duration. A project manager monitor these activities more clearly. So what is crashing, we have discussed it already. So with this we have completed our unit 2. So I told you guys that was the most difficult unit. I was just kidding. It was the most easiest unit you have ever seen in this entire subject. So the next lecture we are going to study about very good topic, that is project management features and agile project management. I hope you enjoyed this lecture. This is more of a theoretical plus a little conceptual lecture, I would say. Just you need to remember few things. I don't wanted to explain each and every things like what is the variance, because it comes like then I need to explain you what is the statistics behind it, how these things are derived and everything. So just remember these things. Mainly I don't know whether these things will come or not, but these are the major things, that most important things that you want to study for the examination. Okay, I hope you like the video. If you like the video, just comment it down. What else you want, what you wanna do, like want in the next lectures or anything else. Just like the video and comment it down. It really motivates. Okay, thank you for watching. Thank you for your time. Bye bye.